Good start. G'day everyone. For those of you who don't know me, I'm James Woods. I'm the chair of the Southern Region for the NZIOB. This is a national-led event, and in the last couple of days I've just been asked to jump in and do the introduction on behalf of our head office. So welcome and thanks for coming. I suppose first thing, welcome to our members and non-members alike. Again, just a quick spiel for the NZIOB. It's good to be putting on events again from our perspective. With COVID, we've unfortunately lived a lot of Zoom meetings and a lot of webinars and bits and pieces, so it's good to get back in front of each other and network again in this event. So thanks to the team here presenting tonight. It's been well anticipated, and we've got a few people online nationally on looking as well. The first thing I want to say too is thanks to our national sponsor JIB. Without their input and help and support of the NZIOB, that things like this wouldn't be possible. Just a couple of things on the radar, I suppose, for those of you on social media, for LinkedIn, Facebook, Instagram, etc. If you are, just follow the NZIOB. We've got some good events coming up for the rest of the year and some exciting things in terms of building awards, quiz, golf, site visits, etc. And we are actually starting at Otago branch, so another sub-branch of the Southern Region down in Otago, which is great. Tonight, we've just got a couple of formalities to get out the way before we kick off into the Antarctic presentation. We've got a couple of awards to give out, which we will do in a couple of seconds. And then after the presentation from the team, there is drinks and nibbles in the foyer where you've all come in, just probably around 7 o'clock tonight. And then we'll hand over in a minute to John. So first and foremost, getting off to our awards, we have two here from the Southern Region to give out. And these are very historical, shall I say. Due to COVID, we've held on to them and haven't given them out. And we just want to take our first opportunity to give them out to the recipients tonight. So the first one is giving out an award of fellow. The first award that we're presenting tonight is the award of fellow, criteria of which the applicant is an NZIOB member who is A, regarded in holding a position of significant eminence, distinction or authority in the building construction industry and contributes to the development of the building and construction industry. I'm pleased tonight to present this award to an NZIOB member who is a construction industry leader who needs little introduction, and that is to Mr. Anthony Lees. A couple more comments about Mr. Lees, but I'll do the handshake. Well done. Thanks, mate.
Thank you, James.
Anthony has, since early in his career, he's been recognised by the NZIOB in the annual awards program, including being the recipient of the inaugural Young Achiever Award back in 2002 and winning the Supreme Award in 2005. And he is the first person to achieve both those awards. Anthony was the chair of the Master Builders from 2007 through to 2017 and recently has been part of the NZIOB Strategy Day in March this year. So I would just like to congratulate Anthony and thanks very much. Well done, mate.
Can I just really quickly say 2002 sounds like a lifetime ago, and I'm sure it was, but you know, I'm only standing here today because I've got an amazing group of people at Lees Construction, you know, from the board down to the guys banging the nails who've made my job very easy, and it's nice to receive this, but it's for them. Thank you.
Well done, mate. Thank you. The second award tonight we are giving out is deemed an Regional Honour Award. And this award, the criteria is the Regional Honour Award allows the regional committee to recognise members of the region who have made a significant contribution to the practice of science or building. The award cannot be presented more than biannually, second yearly, and is presented last time by the Southern Region to Graham Goss back in 2017. The citation for today's award reads, whereas Graham David Earl joined the New Zealand Institute of Building in 2002 and subsequently held senior appointments at Mainzeal, Lees Construction and Naylor Love Construction. And whereas his project skills have been recognised multiple times in the Building Industry Award programs during the 19-year tenure, including winning the Supreme Award in 2008, the NZIOB Awards for Excellence. And whereas his extensive industry contribution has been extensive and includes Canterbury President of RMBA 2008 to 2013, Chair of the Apprentice of the Year Southern Region RMBA 2008 to 2013, NZIOB Regional Committee Chair from 2017 to 21, and NZIOB current National Board Member since 2018. Now, therefore, the Southern Region of the NZIOB formally recognise this outstanding contribution in the awards for the NZIOB, hereby present Graham Earl with the Regional Honour Award.
Well done, Graham.
Thank you very much. A few words.
Oh, a few words. Yep. Yeah, everyone sort of that I've worked with has had a contribution to my career, and I was totaling it up the other day. I've been in the building industry for probably 39 years, right through from carpenter to where I am today. I never thought I'd be doing this role. I was always an operational person getting shit done. But the fact is, I'm really enjoying what I'm doing, and being able to contribute back to the master builders and also NZIOB has been really, really an honour. So I really appreciate it. And thanks to Anthony for what you showed us and taught me as well in the time I was there. So well done. Thank you.
Thanks, Graham. Now, without further ado, I'll pass on to the Antarctic presentation, and I'll pass over to John. Thank you.
Thanks very much, James. Well, it is an absolute honour and a privilege to be here, I will say at last, because I know this has been long awaited, put off because of COVID. So it is a pleasure to be able to be here in person and in Zoom land. So greetings to NZIOB members who are away watching this virtually, to talk about Aotearoa, New Zealand's home on the ice, the New Scott base. I would also just like to say it's serendipitous. If you were expected to see Simon Shelton, I apologise. He has a significant birthday, so I've allowed him to go fishing. So I am John Ager. I am the new project director. I say new, I've been with Antarctica New Zealand now since the 10th of January. I spent a lot of that in quarantine and also down on the ice. And I come from a background of having worked with British Antarctic Survey. So my background is one of project management and program management out on the ice. I'm lucky, and it's serendipitous, that we've also got Hugh Broughton, who's the architect of the New Scott base with us. He happens to be with us going through some of the finer details of the fixtures, fittings and equipment required for the New Scott base at the moment. So we've managed to secure his services here as well. Ian Miller, obviously from Leeds Construction, and you know it's serious when not only your boss, but the board are here, obviously to take quite a significant accolade again, Anthony. So lovely to see you here, but no pressure there, Ian, I would just say. And Will also joins us from WSP, our, again, key partner in this activity. And the one thing I would just start with by saying is this is a really collaborative joint undertaking that we're taking part in here to deliver Aotearoa New Zealand's home on the ice. So it's not just us, and we may be the client, but this is a real team effort to make sure that New Zealand gets the very best outcome from this. So I'm very grateful to have the team here with me at the moment. And of course, I will have forgotten the clicker, having briefed the team on how to use it. So just... So a very, well, I say short presentation. When we sat down with Sam Chapman, who's very kindly synthesized the slides, we had over 200 when we started. So there's significantly less than that now, and hopefully a lot of really good content. There's more here than we can possibly share with you. So we're looking forward to your questions in about an hour, I guess, or maybe slightly less, depending how quickly I speak. A little bit about our place on the ice at the moment, the plan, the design, and then we'll take you through how we're going to build it, and some of the finer details that even I am still baffled with. So I'll probably learn something this evening as well, and then really do welcome your questions. That's a little bit about us, and I think I've just run through that enough. So let me just start by saying that Antarctica, I know a few in the room will be experts and will have been there. We were having a conversation with a few people who are repeat offenders, is an amazing place. And Antarctica New Zealand, like every other organization that works in the environment, plays a real, it's a privilege to be in that environment, and it needs to be kept special. We have a very high standards and values, and we value that environment hugely. And we value working together in the best possible way to get the best from each other, to support each other. And we aim to achieve the very highest standards. And I would also say, not reflected in the slide pack here, is we also have a charter for that broader partnership, the standards and values that we believe and follow in all that we do. So it's a really interesting, unique environment where collaboration transcends some of the geopolitical challenges that you might see in the press today. The coldest, driest, windiest place you can ever imagine. And that brought home to me on a recent trip where the wind chill factor added to a -15. Marcel, you know it's serious when your QS is also in the audience as well, was alongside me, and the wind chill factor in excess of -30, -30 to -35, walking down to what was Scott's hut on Hut Point, really brought home the extreme conditions that those that are exploring the continent experienced in the past and continue to experience in the future. Here you see, and the team will talk a little bit more about the Scott base, the existing Scott base. But of course, we're there in Antarctica because of the insight that it gives us as an organization. It's all about the science and what it provides for us. And as we build up to constructing the new base, we've been relocating some of those science projects over the last sort of couple of months or so, the long-term science projects that have been collecting data for decades. We've relocated some of the cabins that have some experiments called Chloe, which is chlorine oxide, so a key component in the atmosphere, and a space weather project called Aardvark. There's some geomagnetic sensing that goes on there. These are long-term data sets, some of which are unique contributions that New Zealand makes to the broader science community. So really, really important stuff. So whether it's drilling for ice, whether it's space weather, whether it's looking at the broader environment, this is an absolutely critical environment for us. And it's important that we treat it with respect, we maintain its pristine status, and continue to get the insights that will help us address the issues of global climate change. And as I say, an amazing environment where collaboration transcends geopolitical challenges. And of course, it's steeped in history. So Sir Edmund Hillary, famous for their transantarctic expedition in 1957. You'll see obviously one of the cabins there. We still have one of the original buildings actually at Scott Base. It's a lovely color, and I'll segue back to that later at the end of the presentation. But steeped in history, the current challenge, though, is not far off what you would see there from 1957. The buildings are of an age now where they're reaching the end of their useful life. And as much as it is an amazing home from home on the ice, incredibly well connected buildings, well established, great living environment, very much a disparate bunch of buildings put together on a very uneven surface, very difficult to access and to maintain, a lot of old equipment, and clearly reaching the end of its useful life. Not unsafe, but unsustainable for the longer term. And that then is the challenge that we have to try and set up Antarctica and our research capabilities for at least the next 50 years. And I'm going to hand over to Hugh now, who hopefully is going to be able to explain how he's designed that.
Thanks, John. What a pleasure it is to be amongst you all today. I flew in on Saturday, my first time back in New Zealand for just over 2 years. A lot of time on Zoom spent during those 2 years, and to be here actually in person with real people who are really going to build Scott Base is just totally awesome. And particularly great being here with John, Ian and Will, who are such incredible partners to this process. The exciting bit's going to come a little bit later when Ian tells you how we're going to build it and Will tells you what it's going to be built of. And I'm just going to give you a quick architectural overview of how the building is arranged. As John has alluded, there's a lot of things go on at Scott Base. A lot of science is carried out there. A lot of expeditions go out onto the ice. And it comes, despite being in Antarctica, with quite a number of significant challenges. In fact, you'd think, oh, well, Antarctica, there must be endless amounts of space in which you can build in. There's actually quite a lot of restrictions around the current Scott Base. For example, there's a road that leads from airfields to McMurdo Station, which pens in the site on one side. There's the sea on the other, which is frozen for most of the time, but defrosts sort of once every 2 or 3 years on the other. And then there are long-term science experiments on the further side of this image. And then in the near side, there's staging areas for all the containers that are needed to bring in food and supplies and take out waste back to New Zealand. So actually the areas we have to build in are pretty restricted. Added to that, of course, there's an existing base, and we're looking to reuse that as accommodation, not only as we plan the building for the science teams who go out to Antarctica, but also for the construction team who will be building the new base. So, yep, in Antarctica, but almost like a city centre site. So early on, we started coming up with concepts. Could the building be long and interconnected? Could it be a series of step buildings? And slowly, through a process of investigating different concepts, analyzing the benefits and disadvantages of each, we honed in on a solution which we've now been developing over the last 2 or 3 years. And the idea is really pretty simple. Scott Base is located on Pram Point, where Sir Edmund Hillary established it in 1957. And it's a sloping site, sloping from Crater Hill down towards the sea. And because it's on that slope, we've utilized that in the design of the building. So there are 3 identical width buildings stepping down the slope of Pram Point and connected by bridges. So maintaining that concept of interconnection established by Hillary and reutilized in the buildings redeveloped in the 1980s, and which will also be a key feature of the new redevelopment. So the upper building contains living accommodation, recreation and welcoming space. The middle building is the primary science facility. So that's where the scientists will be working, where there are labs, but also there's admin spaces and where all the expeditions are prepared for going out into the field. And the bottom building contains storage, workshops for looking after all the vehicles and so on that are needed to facilitate those expeditions, connected by bridges so that the lower level of the upper building connects to the upper level of the middle building, and the lower level of the middle building connects to the upper level of the lower building. And then there are lifts and stairs making those connections, so the building becomes much easier to move equipment around compared to the 11 different levels of stairs which you find in the current base. And then with big zones for the distribution of services, again, addressing that issue which we have in the current Scott base, where many of the services are reticulated in very tight zones that you need an army of 5-year-olds to help maintain. So this is the existing base that people will probably recognize, the existing Scott base made up of a series of interconnected buildings with links joining one to the other. And here the simplified concept of just 3 simple buildings interconnected with bridge links, stepping down Pram Point with helipads at the bottom, staging areas off in the distance there, and then the bottom one is the highlighter. Oh yeah, nice. And then here, that original building from Hillary's first Scott base built in 1957, which I don't know who has been there, but it's just been really beautifully restored by the NZ Antarctic Heritage Trust in all the right colors and everything, an amazing piece of conservation work. And here we see the new base in the context of Ross Island. Ross Island, of course, is unbelievably historic in terms of the annals of Antarctic expeditionary endeavor. It's where Scott set off to the Antarctic. It's where to the South Pole. It's where Shackleton set off. Many of the old huts are close to here. Both Scott's huts and Shackleton's hut are close to here, as well as Borchgrevink, who was one of the first people to explore in the Antarctic in the early 20th century, and is actually the oldest building in the Antarctic, Borchgrevink's hut. And you can see Scott Bay, the planned Scott base here, and McMurdo, the US station, just over the hill here. And the development sort of works very much in tandem with the redevelopment of McMurdo, which is ongoing at the moment as well. To develop our design, we've consulted with as many people who have been to Scott Base in recent years as possible. That's both employees of Antarctica New Zealand, but also with multiple scientists. We've had 26 workshops, 4 series of workshops, some in person, some over Zoom because of COVID, and consulted, well, probably now over 150 different people. We've also had a great process of cultural engagement within the project, which personally as an outsider, I found particularly interesting and exciting. One of the great things we did just before COVID is we managed to get in an overnight hui at the Ruahua Marae in Christchurch. And here's the pictures of us all fresh-faced in the morning after sleeping within the marae, And it was a really great opportunity for talking not only about how New Zealand's culture would be overlaid in the design of the building, but also how the history of Scott Base itself would be reflected in the new building. Key to that is understanding the history of Hillary's own building, the Antarctic Expeditionary Hut from 1957. We looked very carefully at the original colours, which were so carefully recreated by the Antarctic Heritage Trust, but also at the colours of the outside of the building. There's a very homely kind of environment, something that we wanted to recreate in the new base. So I'll just give you some ideas of what the new base will be like, both internally and externally. So this is the entrance towards the building with the dining room up on the upper level so people can look out, engage with their incredible surroundings. As you come into the first building, which is the living and accommodation building, it's arranged around a kind of double height circulation space. So longer term residents have their own room looking out into the landscape. Short-term visitors, scientists going out into the field will share a room looking into this double height space. And on the lower level, that's where all the plant, food stores and so on are arranged. So quite a simple arrangement for carefully maintaining during the winter. In terms of making the space seem as homely as possible, but also helping people cope with the effects of seasonal affective disorder, which is a big issue in the Antarctic in the winter darkness. We've employed a colour psychologist. We've been working with her recently, and she's developed a special Scott-based palette. And then we've been gently applying that through the building. So this is that double height circulation space. You can see photographs of all the winter teams on the left-hand side, and then some commissioned art piece at the end of that double height corridor, just again, giving that sense of place, which is going to be such a strong feature of the new Scott Base. And then just some of the other interior spaces, combinations of single rooms, twin rooms, quadruple rooms. You see the ablutions on the top right-hand there. And then this is a library at the far end of the upper level of that first living building with amazing views looking out over Mount Discovery. You know, really nice Southland Beach ceilings, quality furniture, books that come from Antarctica, New Zealand's own connection, allowing people to constantly connect with their environment, as well as find out about some of the amazing science which has been conducted over the years at Scott Base. Of course, no project would be safe without a little bit of value engineering. So with ACOM's great help, we've been going through that process recently. And I think one of the amazing things I found about this project is an incredible team. Antarctica New Zealand have done an amazing job at engendering a really strong team spirit. And, you know, I like to think, guys, I've made some lifelong friends through this process, which I think is something quite unusual, certainly in the construction industry in the UK. And it feels very special to be part of that on this project. And it's made things like this value engineering process so much easier to work through. And I think we've made some positive changes, which have also saved money through that process. One of which was just looking at our bridge link, which was a little complex in form, simplifying its shape, but then actually making it lighter and brighter in the process. The middle building is the one that's used for science. Again, flexibility is the key. Big open plan spaces to get expeditions ready, surrounded by cleaner spaces to calibrate things like electronics and other pieces of expensive experimental equipment. Then with labs and open plan workspace on the upper level, and then a roof deck for people to put their experiments. And here you can see what that collaborative workspace would be like. And then the more industrial space for getting your expeditions ready at the lower level with cages, which can be reconfigured according to the size of the event, or the whole space can be open plan. It's all very regular shaped spaces with a repeating 6-meter grid, making it very flexible for future change. And then down in the bottom building, building C, we're more into kind of workshops, storage. So you can see as a building, it's quite interesting because it ranges from sleeping accommodation, dining spaces and libraries, right the way through to vehicle workshops and wastewater treatment plants. So it's a sort of microcosm of a sort of small community, I guess, with everything you need in order for people to survive through a long, harsh Antarctic winter. And just finally, I thought I'd tell you about the cladding. Will's going to tell us about the structure, which is a repeating steel frame. part of this project has involved really reaching out into the global community to find the absolute best expertise for ensuring that it's the design most fit for this extreme environment. So we went to Canada, for example, to look at how to minimize snow drifting around the base by elevating the buildings. We also went to some wind tunneling in the UK, where they built models of the building, put it through the wind tunnel, and we discovered that our maximum wind pressure is 10 kPa, induced by wind speeds of around 180 kilometers per hour. That's around 4 times more than is required to be withstood in the New Zealand building code. So you can tell in some places, this building is going to get an absolute hammering. So we really need to be careful in the way that we design that. Whoops, that's a bit of a weird image, slightly distorted, but looking up at it, and what we're seeing here is a building largely clad in metal composite insulated panels, so a Kingspan type system, but then using high performance glass reinforced plastic designs for those key points around the gable ends, which make sure that the wind pressures are not exerting too much of a force in the areas of highest pressure. So just helping to direct the wind around the building, keep the snowdrift down, and reduce the pressure on the building. So that's the architectural overview. How are we going to build it? Ian.
Question you. Looks very nice.
Thanks, Hugh. Yeah, it's going to be a challenging and interesting project. So thank you very much for having us along tonight to talk about it. So this is pretty unique. In the planning of this, we looked at the traditional stick build method and thought it would take about 10 years by the time you have to containerize, build, and decommission. And aside from that, you would have needed a huge amount of people. And of course, there's not a great deal of accommodation at Scott Base. So that drove the methodology, which is a modular construction. So this is a great cartoon. There's a cartoon here, I suppose you call it that, of the methodology. So it's really 4 parts to it. There's a New Zealand-based construction and a very significant piece in the middle, which is quite a complex transportation case, which I'll talk about. Then there's the on-site construction and the decommissioning of the old base and the recycling of as much as we can out of the old base and materials. So the Timaru construction, I'll call it standard. It's a reasonably complex building, as Hugh said. It's a small town, so it has everything you can imagine it needs a town to run. Wastewater, reverse osmosis water production, fully reticulated services, quite a complex fire suppression system, and obviously bedrooms, kitchen, you name it, it's got it. So it's, we'll talk about the interiors shortly, or the structure shortly, but it's a traditional build, but beefed up to withstand primarily the shipping case. So as it travels across the Southern Ocean, you can imagine there's going to be a lot of interesting forces at play on that structure. So we'll talk about that in detail after me. So a part of the Timaru-based construction is accessing a ship for the modular transportation. So the construction of a roll-on structure is required to do that. So in parallel to the build in Timaru, there is about 3 years of site preparation and to prepare the site ready to receive the modules. So part of this is obviously bulk earthworks. There's about 65,000 cubes of material, and we're balancing that out on the site so there's no material removed. Transition road, so, oops, damn it. This road here is a new alignment. That's the main arterial route for McMurdo Station and Scott Base to get out to the airfield. So quite an important piece of work there. So road realignment, currently it moves down the hill and around. Temporary wharf and bollard construction. So we need to build a structure to receive the ship when it arrives, and that's a roll-on, roll-off structure. Quite a lot of bathymetry around, obviously making sure that the ship can actually get into that site. There's no underwater blasting allowed down there, so it'll be, you know, quite a complex piece of work to design that structure. And all through this, we've got to maintain current operations at Scott Base. So the staging aspect of this is pretty complex. I love this picture. This is the vessel that is going to arrive in Timaru in a few years' time, and we're going to roll the structures onto the MC class vessel. There's about 5 or 6 of these in the world, enormous vessels. So there's a lot of planning around the loading of the vessel. So as the modules are rolled on, you've got to maintain ballast for the tide, obviously to keep it at the right level, and the weight of the ship as the load moves from one side to the other. The site access and mooring at Scott Base, as I mentioned, is quite a complex piece of work to make sure that the ship can obviously be kept fast in that position while the modules are rolled off. And amongst that, we've got sea ice. We'll talk about that in a little bit more detail later. And the Southern Ocean, the voyage. So as you know, the Southern Ocean is a wild stretch of water. And as such, there's been quite a lot of work done to model the movements of the ship. And we've used a lot of historic weather forecasting and information to backcast what the sea state may be at that time of year. So that's the vessel with the modules loaded. There's 8 building modules. There's some ancillary containers and so on that go down on the traditional ship. But yeah, 125 meters long by 42 meters wide. So it's a large vessel. There's a lot of work involved in securing the modules, obviously, to the deck. So they'll be transported across the deck. They'll have steel stools set up underneath, and those stools are then welded to the deck. Once we're at Scott Base, the ship carries out what's called a Mediterranean mooring, which I knew nothing about. So essentially it backs in and into a fender structure, which you can see here. And as part of the construction, we have to build that structure and install about, I think it's a dozen odd bollards to hold the ship in and keep it from moving while we're offloading. That's just a picture of what it looks like underneath. So ice breaking is another piece of this puzzle. In order to get to Scott Base in the middle of summer, the sea ice is still there. So you need an icebreaker to break a channel, sometimes as long as 50 kilometres from the ice edge, depending on the sea ice conditions. But not only that, we can only arrive after a certain date. So the Weddell seal population happen to have a wonderful nursery right outside Scott Base. So we cannot move, obviously, get an icebreaker in there until the pups are able to get out of the way, essentially. So that limits the arrival date. The sea ice conditions obviously dictate how long the breaker will need to break the channel. So this picture here, that's McMurdo Station here, Scott Base, just around the corner, about 3 kilometres from McMurdo, so quite close. This is the US breaking ice in their standard season. So yeah, it's a complex programming issue. You've got to arrive not too soon and not too late. If you have your buildings sitting on the ship too early, sitting waiting for the breaker, you can get storm katabatic winds coming off the polar plateau that, you know, could wreak havoc on the buildings. So there's a lot to think about there. Another great photo. I mean, this project's been fascinating to deal with. These both of them are Dutch companies, actually, Mammoet and Big Lift. So Mammoet, I'm not sure if any of you are familiar with these guys, but you know, they are the global experts in heavy lift. They were talking last night in a Zoom meeting about a 6,000 ton crane, ring crane that they're using at the moment. Just extraordinary. We're very nervous about this process, but they shrug their shoulders, do it all day. So, you know, that's a great deal of confidence. So the modules in themselves are not that heavy, but they're obviously bulky. We've got quite a precise loading sequence, how we load them onto the vessel in order, obviously, to get them off in the right order. And the positioning on the piles, I think the next slide, no, it doesn't, it's later on. The positioning of the piles on which to place the modules is a precise piece of work as well. So we're modelling about 1 module per day off the ship. It's a walking pace. It's on about a 9% grade. I think it's the steepest that these machines will go up. We've got a bunch of winch blocks as well to make sure that there's no issues for traction. So, I mean, it's a really interesting piece of the project. this is just a roll on. So the site at Timaru, obviously the modules will be built. We're going to commission the buildings in Timaru, do all our testing. So we're going to put them together, commission, test, and then pull them apart again on the trailers, the SPMTs that we just saw, and then down the haul road and across onto the vessel. Scott-based roll-off, a little more complex given the topography. So there's a lot of civil construction ramps and access roads to be built to make sure that the tolerances of the SPMTs, the modular transporters, are not, are not breached. They can move about 300 mil up, 300 mil down, so 600 mil of each axle on those trailers, independent movement. So, it's a pretty fine and precise activity, particularly where you've got transitions where the buildings start to move up the slope. You'll have the front of the buildings going up the slope while the rest is still trailing along behind. So some pretty interesting calcs going on there. Yeah, this just shows the methodology for positioning the modules. So we'll have pre-piled, I think there's about 300. I can't remember the diameter of the piles, Will? 410 piles, and they're iced in. So the old Antarctic cement, you drill the hole, you put the pile in, then you pour water in and leave it to freeze. It's simple as that. So essentially the pile lines are in, and we'll build a ramp system underneath the piles to bring the modules up to the right level, drive over the top, and then lower the modules down onto the piles. Sounds really easy. I'll move on from there. So I thought I'd talk a little bit about the unique challenges. I mean, obviously construction in itself is challenging at the moment, let alone the unique Antarctic specific ones that we'll be dealing with. The weather and the ship routing, which I talked about, this is a model based on a whole bunch of data that talks about, the probability, likelihood of achieving the voyage in certain sea states. So the design limit is 6.5 metre wave height, which translates into an acceleration. We'll talk about that more after this. But essentially, we looked at the routing. That's obviously a dead route straight line. The weather's often doesn't allow for dead route straight lining, so we've had to ensure we've got enough program contingency for the ship to make its run. They have a pretty sophisticated weather forecasting and modelling system on board the vessel, which makes appropriate adjustments of the course depending on the forecasting and the predicted accelerations. The logistics. So I think this project's probably 50% logistics, I think, maybe even more. It's complicated. There's shipping and airlift capacity. The airlift is limited ability, and of course, it's fairly intensive on the carbon. So we're trying to maximise the shipping capacity, the shipping utilisation. So there's a 12-month cycle for the ship, one ship a year. So if you miss the ship, you miss a year. And I think that's really a very important thing when you're planning to get your head around is if we don't have gear on the ship this year, we miss next year, it won't be there. So you have to have everything planned a year in advance. Otherwise, you have to rely on the big beast, the C-17. And I mean, they're an amazing aircraft. That's a 40-foot high top container with about 30 tonne in it. So they're an amazing aircraft if you do have to get something down there in a hurry. But the ship is obviously the primary. Construction season is limited by obviously the weather, but also the darkness. So mid-October to about February is our construction season down there, about 4 and a bit months. And during that time, you've got 24-hour daylight. So there is a bit of flex in the system. If you do get behind, you can obviously catch up in the daylight. But once about April comes, it's all over. You've got no light. So, the construction season has absolute hard dates around it. So program and getting work done in a specific season is critical, because if you don't get it done that season, you're not going to get it done until the next season, 12 months later. We've talked a bit about the site work staging, but the base, they're still planning to deliver a full science program whilst the works are going on. So, you know, there's a lot of interaction with helicopters, haglins, you know, all sorts of plant and people in and around the site. So there's a heck of a lot of work going into staging the construction works, particularly when we're building the ramps for the modular transporters. So we have to keep the base access open at all times. Operating temperatures. Yeah, I mean, it is a cold place. The weather in summer can actually be reasonably benign, and we don't, you know, we get long periods of pretty sort of overcast, sort of -5, -10. So it's actually pretty good most of the time for 2.5 months. Either side of that, though, you know, it gets down, as John mentioned before, you know, once the wind chill gets up, I've been down there with a wind chill of -70 in October. So you just can't work in it, it's dangerous. And so that's managed pretty carefully. Once sort of February, March comes around, you know, it's getting down to the -30 plus wind chill, and, you know, it gets pretty uncomfortable working in those sorts of temperatures. Drift management and winter storage is a big issue to manage. So you can see here, this is just after one storm. That's the machine, that's the mechanics workshop. And these are the wind turbines from a few years back. So everything has to be lined up again with the prevailing wind so that you can get as much blowing over the top as you can. But ultimately, he took the slide out with the lot stuff in it. We had an issue one year with when a container with a soft top on the top ripped completely off in the winter, and the spindrift just packed like tight polystyrene into a wind turbine nacelle. So it was 3 or 4 days of careful scraping of the snow to get it out of this container. So very important that we manage that winter storage. So yeah, we've got I've talked about the climate, but part of that is not just the cold, but the UV. So intense UV, so sunburn, dehydration, and so on are very big risks down there. Marine offload, talked about that. That's a reasonably high risk venture. Sea ice and snow, pretty obvious. But the remoteness, that really plays a part in managing people. When you're down there, your connectivity is extremely limited. You know, you can't just get on the old Google or internet. There is facilities do that, but we have to manage it carefully. Circadian rhythms are also a major. Some people with 24 hours of daylight, their sleep just goes completely out the window. And after a week of, you know, walking around the base in the middle of the night, people get pretty grumpy. So that has to be really managed well. And some people can handle it and some people not so well. Yeah, the remote from family, you're talking 3 to 4 months for some people. So it's a long time to be away from friends and family. And yeah, the unfamiliarity of the environment, it's a strange place. It grows on you after a few months, but when you're there at first, you know, for the first few weeks, it's a very odd place to be, and it takes quite a bit of adjusting. So you have to, you know, we're wanting guys to get there, get on site and crack into it just like you do here, but we have to develop some mitigations and you know, assistance to help them do that. Cold weather, obviously PPE is critical. Dexterity, so glove use. Some people's tolerances to the cold are different to others, but you know, just design is a key there, and designing systems that can be done with, you know, tighten whatever with gloves. You know, even simple things like goggle fogging, you know, it's an issue. Your visibility can be impaired, and suddenly you're tripping over and whatnot. Moisture management also, you can get warm, you sweat, and then if you're not layering properly or delayering, you get, you know, you can get very cold very quickly. So, you know, there's a whole bunch of mitigations around that. Warm up facilities, increased calorie intake. This food's bloody good down there, so there's typically no issue there, but it's a real thing. You've got to keep hot, regular food into the guys that are working outside. There's a lot of systems around, you know, buddy management, but frost injury monitoring is a very important piece of this. Frostbite and frost nip. Once you get frostbite, that's, you know, your tissues died, so it's not a good thing. So it's to be avoided. Finally, but not least of all, environmental management. So as you can imagine, extremely strict protocols, rules, regulations, etc. around environmental management. Waste handling, you know, every time something blows away on the ice, it's an incident report. So, you know, you can be filling out a lot of paper if you're getting it wrong. You know, and you don't want it to be obviously either. Wildlife, we've had Adelie emperor penguins totter onto the site, and once they're on site, you can't move them, you've got to leave them. So prevention of that happening in the first instance is really important. So that's all I had. There was one slide which hasn't made the cut, but I would like to read it out just to give you a sense of the history and the early days of what they dealt with. This is from a guy by the name of Apsley Cherry Gerard, who wrote a book, which is a great read, The Worst Journey in the World. We stood panting with our backs against the mountainous mass of frozen gear, which was our load. There was no wind, at any rate, no more than light airs. Our breath crackled as it froze. There was no unnecessary conversation. I don't know why our tongues never got frozen, but all my teeth, the nerves of which had been killed, split to pieces. So hopefully that won't happen, but that was a winter trip. We won't be doing any of those. Anyway, I'll hand you over now to Will, who's going to talk about the tricky stuff.
Cool, thanks Ian, and tēnā koutou katoa. It's really great to be here tonight, to have real people in a real room, and also a lot of my colleagues here. It's quite exciting to see these people we haven't seen for a couple of years. And I guess just going back to John's comment about the team, Antarctic New Zealand have put a lot of effort into building this team because they understand the importance of that. And from the marae visit, and also just talking about getting to know each other and becoming friends, like when we got together to do the charter at the end of 2017, I ended up in a bunk room with Ian, which was a good experience. And then when I went to Antarctica New Zealand when Antarctica got based with Hugh, I ended up sharing a bunk. I think I was on the top and he was on the bottom. So it's different to a normal project, and you do have those opportunities to build that connection. And I think it has made a real difference. And I think it's paying off now because there's a lot of challenges. And yeah, that makes it really interesting too. All right, so look, I'm going to really talk on behalf of the WSP team, Civil, Structural and Geotech, because it's the hard work of everybody that really makes it possible. And just kind of go through, I thought it was really good if Ian went first, because I guess when Lee's got involved in the early contractor stage, it did kind of mean we had to relook at the design. We kind of kept with the same modular system that Hugh's talked about, but building it has had, basically we've redesigned it to be built that way. So that's been really interesting, and it's been a team effort too. So Ian showed this slide, but the key point is it's really designed to be built this way. So that has changed the design. Okay, so what's kind of normal and different about this project? Well, it's kind of obvious, but it's kind of good to think about it too. So yeah, what are the loads? They're not defined in the same way as a normal building. You've got to think about them. You know, what's the wind? It's a special study. It's not something that's just kind of in the standard. So environmental conditions have been mentioned, but you got to think about that. What can you do outside? I mean, when Ian said, let's not have any, you know, bolts that are too small and fiddly with structural engineers. So he said, good, you want big bolts here, no problem, we have big bolts. But yeah, like all your products, you know, you've got to just go to more rigor to make sure they're going to do the job that they need to do in that environment. Construction, we've talked about that. And precedents, you've really got limited precedents. A lot of the things that we're doing have been done before, but not all together in Antarctica. So people have shipped really big things, but not that sort of building to Antarctica and then built a Mediterranean wharf and taken it ashore. So some of that's new. Okay, so what is the building? Just to go through some basics, I'll try and make it, you know, not dwell on it, but it's an IL4 facility. Obviously, it's got to be post-disaster. When you're thinking about fire, you can't just get people outside because you can't necessarily escape outside because it could be a condition 1 storm. So you've got to think about refuges and firefighting or containing within the building. And I guess what we did in terms of the main difference was we understood pretty early that wind was going to be critically important, probably more than seismic. And so we kind of brought in this damage control limit state to really make sure that we got the performance we wanted in the sort of relatively high winds you get frequently. So just to talk about the other natural hazards, because this is kind of interesting. I think it's a little bit different to normal. So we kind of did, there was some talk about tsunami. So we're kind of like, well, this thing is quite near the shore. So what could that look like? So Antarctica New Zealand engaged GNS to do a little study, and they found that you could get a big central American earthquake that could generate quite a significant tsunami. And that could actually run up to the 8-meter contour it's got base. And that's pretty close to the existing base. So, you know, that was one of the reasons that we have made sure the facilities are a little bit higher. In terms of seismic, yeah, it's pretty low. But the interesting thing was GNS said, well, we don't really have any records, so we don't really know what the seismicity is. And they found some plates that were fairly similar in Germany, and that's how they figured out what the seismic activity could be, which might sound a bit random. There are ice quakes as well, but they're not the size that would really bother the building. And then volcanic eruption, that's quite interesting. Obviously Mount Erebus, which is pretty well known, sort of 40 k's away. Ash clouds, what could that do? That could drift down to the base, but again, didn't affect the structure, but it was something that we had to think about in terms of ash on the roof and water supply, all that sort of thing. And I guess just sea level rise was pretty interesting as well, trying to predict what would happen in the future climate, knowing that climate change is a big factor. And some of you will probably know that in the poles, when the ice sheet contracts, it actually reduces the gravitational attraction at the pole. So the sea level can actually go down locally, even though it's going up in the rest of the world. So that's why you can see the line kind of dropping there as one of the predictions, but it's also predicted to go up. So somewhere in the middle is the effect, and we have made an allowance for that. So interesting stuff. Oh yeah, obviously the change in the permafrost, I'll get into that in a minute as well, was something we looked at. And I guess just what's different to normal, as you've heard, there's everything in the building, including vehicles, quite heavy kind of bulldozers that are being maintained, but there's also water tanks and wastewater treatment plants. So just in the table there, I don't know if you can read it, but the heaviest floor loads are 30 kPa. So, you might say for an office, you're normally 3 kPa. So like 3 fairly big people in a square meter. So this is kind of like 30. So it is a significant demand on the building. And then I guess looking at how we handle the transportation and what we do. So I guess what we've done is a combination of the structure we had before, and then a combination of beefing it up permanently. So some sections that are bigger to handle the transportation demands on the structure, and also some temporary braces that we can take out afterwards once we get down there. So, and this is just to look at what happens in the ground. This is quite an interesting angle in terms of the foundations, because the ground's frozen. And if you look on the left, let's see if try this. So this is basically your seasonal profile. So your ground level kind of comes up close to freezing in the summer, and it stays down here at -20. But then if you look at it as a sort of a depth profile, in the summer, you can see it comes up here to sort of above 0. And down here, it stays down here at about -12. And in the winter, it's pretty cold still down here, -24, but it's much colder at the surface. So you've got quite a lot of change in ground temperature at the surface. So you just got to think about that in terms of where you put your foundations and the impact that'll have on any foundation. So we've decided on a piled solution. There's a few reasons for that, but it works particularly well with the delivery methodology, because it's a lot easier to roll your building over the piles than over pads. Pads have been done before, but the real advantage of this is that the buildings that we're putting on are actually a lot heavier and more substantial than the existing buildings. So we get a lot more capacity out of this. We've kind of come up with this pile solution here. It's got a thermal break here. It's basically a steel tube. We built one this summer just to test it out. And as Ian says, they're stuck in the ground with water, which obviously freezes. But the thing that we've got is this little grout plug down here, which is special cold temperature grout. And what that means is we get a lot of end bearing capacity out of the pile. So it's a lot more efficient in terms of the number we need. So that's been, I guess, probably the main kind of, I suppose you call it an innovation in the ground. Oh yeah, just go back to that one, sorry. The other thing is that because it's Antarctica and environmental is incredibly important, they're designed to be removable. And during the test, we did do that, took the lid off and stuck a big Herman Nelson heater on it. And we'd done some modeling how long that would take to melt the water, and it was pretty much bang on. So that was kind of encouraging. So you can just pop it out of the ground when you're building your new Scott base, and hopefully at least 50 years, but maybe a lot longer. Okay, so just to pick up on what Ian said, this is how we get the modules on the ship. And I guess, so we had to basically design the building for when it's sitting in Scott base, and it's largely wind dominated, but it is also for the piles earthquake governed, and the transportation methodology. So as Ian says, the shipping has really dictated a lot of the structural demand on the structure, as well as the moving the things, the modules on the SPMT. So we'll just get into that a little bit more. So This just shows you a model of the building, and essentially because it's sitting on these trailers are hydraulic and they're all linked, it's kind of like putting the building on a waterbed. So it just wants to move with the building, and that means that the building has to be stiff enough to resist that deformation. And each module weighs about 900 tons, so it's pretty heavy, 25 meters by 25 meters. So a fairly big, heavy chunk of building. And I think Ian's mentioned the rest. We've got the 3 strings of SPMTs there sitting underneath. And just I guess a little bit more on the SPMTs when we get to site, because in order to be able to turn the modules, you have to do that on the flat, because otherwise you're distorting the whole building. So you're introducing a lot of demand into the building. So each of those turning circles you see on the plan there, they're all level, and that really constrains the geometry of that whole road as well. So important stuff to consider. And you can see here how they can adjust due to this alignment with the hydraulics. And it sounds a lot, sort of plus or minus 300, but when you've got a 1 in 10 slope and flat areas that you've got to get onto and then up off again, that is actually quite constrained on the site. So yeah, it's a good challenge. All right, so just to look at the shipping case, and I won't spend too long on this, but it is quite involved in terms of understanding the accelerations that you get. You can get that information based on the ship type. But of course, there's limited data for the Southern Ocean because not a lot of people do this sort of shipping down there. So we've had to sort of derive some of that and use this design code that we've come up with. This is an image of what the module looks like on a 20-degree deck roll, which is one of the cases we're looking at, more like the ultimate limit state, around about an 8.5 meter wave. So that puts a lot of demand on the modules. There's sort of numbers we're talking here up to 2G in the upper parts of the buildings. So this actually dictates the design of all the interior fit out more than you inside or anything like that when it's in service. And we've also looked at more like the 6.5 meter wave height, because we're going to get potentially hundreds of thousands of cycles. So it's kind of like it's got a fatigue effect on the building as well. So I've had to look at a lower level of seismic, which effectively is a heck of a lot of load repetition. So things you don't normally get into when you're designing a building, but really important to make sure that we get the performance we need. And for instance, we don't get down there and find a problem. So thinking about all this stuff ahead of time is the key. So just a bit on material performance. Some of it's kind of well known, and I guess this picture here at Mawson, which is one of the Australian stations, gets thrown up because they got a wind turbine there and the nacelle fell off the top. It's actually not a temperature issue. It's actually a fatigue issue because the bolts weren't tightened as they should have been. Leave it at that. But yeah, you do have to think about your material choices really carefully. Steel, if you get your grades right, that can handle some lower temperatures. You'll see most of our steel's tucked within the insulated envelope, so we don't have to think about the extreme cold down the -60, but the piles definitely we need to think about. Timber, it would be a great material, but it shrinks a lot because the humidity is incredibly low down there. So yeah, there's been an issue, for instance, down at Scott Base with fire doors, because the timber doors were taken down and then they shrink and then they don't meet the minimum clearances for a fire door. So yeah, it's something that we thought about, but in the end, we haven't gone down the timber route. Concrete, yeah, you need to think about your mix design because of freeze thaw, but you can do it. But obviously, you don't want to be pouring concrete down there because everything's so cold, pretty difficult. And thermal expansion, again, that sort of temperature change in the ground that we talked about, we've got the same thing, which I'll show perhaps in a bit more detail on the next slide. What we talked about, just pouring water and freezing all the piles and job done, cantilevering piles, that sounds all good. But what, of course, would happen if we did all that in one go and then the building got cold? We'd actually have a differential movement of 30 mil, and that would almost be enough to yield the piles. So what we actually have to do is have a sequence for icing up the piles so that basically they can move while the building shrinks, and then we ice them up. So all that stuff's been thought through. And then just how we basically bring the modules together on site. This is a absolutely joined up effort with the building services engineers and the lease team. So we've got locating pins on the piles, and we've also got these locating pins around the perimeter of the frame to lock the frames together. And then we've also got, because we got concrete, which are now in situ floors because we're casting them in Timaru, but they need to be locked together to give the structure its integrity as well. So that's kind of how we do it. And yeah, it's been a fascinating journey. So that's my last slide. So I'll hand back to John just to finish this off.
Right, simple as, eh? So when? We're on the journey now. It's been going a while. And obviously the team were incredibly lucky to get funding last year. Given all the other challenges across the nation, across the globe, I think that's quite amazing. So we're on the journey. We had an early contractor engagement, pre-construction services agreement with Lees to get us through doing some preparatory work for last season. So we've got our long-term science cabins and things already in, and we're working those through. Same again for this season. And then we look to go into full construction at some point early-ish into next year. We've got a little bit more time to spare though, which is quite good news. So the long pole in the tent has been the certainty around when we want to ship the modules south. And I'm pleased to report that we have, through our main board approval and the Leeds board approval as well, agreed that we will commit to the big lift contract. So we're in the process of taking that forward right now. And we're committing to a shipping date at the end of 2026 and beginning of 2027. So the 26-27 season. So that'll see the shipping container and the shipping modules installed at Pram Point in early 2027, which is really quite exciting. We had a business case that allowed a little bit of schedule flexibility in there to allow us to actually mature our design and understanding. And now we have an understanding of the challenges ahead of us, mostly global at the moment, as you can well imagine, and our understanding of what we need to do to achieve that. We have gone with a particular solution, which now gives us a little bit more breathing space to do all the other things. That said, the team have been working incredibly hard over that space. And Sam would remind me that this isn't just about the main base. We're also putting in a new wind farm, which is going to make us generate 97% of our energy using renewable energy, which is an amazing thing as well. So it's parallel activity. And in order to deliver the best value for money solution, as we've all had to tighten our belts, we're not creating a temporary base while we construct the main base. We're actually embedding and modifying the existing base to reduce costs, but also to actually minimize our environmental impact as well. So we start this season on creating the enhanced base, so the temporary base that will support the construction activity in future seasons. And there's a lot of activity you can imagine trying to put in the additional capacity into an existing functioning base that's delivering life support and science. So there's a lot going on in this season and the following season. So I think we've reached a really good balance of activities there. So on here you can see this is probably just the updated timeline. So thanks very much for that, Sam. It's brilliant. We worked through a couple of years of building in Timaru. Then we'll prepare and have following commission. We'll ship south in hopefully December 26 and install in January, February 2027. It doesn't compromise the completion date for the project, which was always going to be 2028. And then we'll obviously complete the demolition and stuff. A couple of other points really worth putting out there. And we talk about the environmental impact. And as I said before, maintaining the integrity of the environment there is at the core of what we do. Everything we do has a comprehensive environmental evaluation associated with it, and that has to go through ministerial approval before we can go and do anything. It's not a one-off. We're going through another review based on the changes that we've made, and that's happening right now. So that's a really important part of what we do. We talk about the logistics case. We work very closely with our US partners through the National Science Foundation and United States Antarctic Program. And we talk about McMurdo. So we share a lot through that. We actually generate energy in Antarctica that goes to McMurdo, and we benefit from a joint logistics pool, which gives us flights. In many ways, very little money changes hands in Antarctica. It's all done on goodwill and trade, which is great to see. The remediation piece in terms of our environment, everything that we do has to be removable and brought back to New Zealand. That's what we will do with the remnants of the old base once it's done. And two final things, which I think are really quite remarkable. One, that Anthony Lees reminded me that Lees have been part of the Antarctic journey with Antarctica New Zealand for the last 20 years. So 2 decades of being with us in Antarctica. And I think that's quite a remarkable thing. And the other aspect I would just flag up is on Monday, the New Zealand public get a chance to help us choose the colour of the base. So we are running a campaign starting on Monday. There are a choice of 3 colours. We're very careful what we wish for. The fantastic green that you see, cucumber green, I think that's right. There's a fantastic blue, and there is a fantastic orange, very akin to the dark orange you see on the heritage hut there as well. And there'll be a chance to have your say over the next month or so. So spread the word and look for the campaign, but it's going to be a fantastic way to engage with what we do. And that is probably enough. And we'll be very happy to try and field any questions, not too tricky, please. Sorry, at the back.
Oh.
Hi.
Yeah, how long does it take to go from Timaru to the Scott Base?
So for the ship journey from Timaru down to Scott Base, well, again, it depends on the weather. And so we've got a shipping window.
Yeah, so 8.5 days is the steaming time if you get good weather in a straight line.
Right.
So we've allowed quite a bit more than that. And the captain obviously makes the call on the design. So the vessel voyage is dominated by the design limit state, so the structural design. So the captain has the call on when he leaves or he leaves. And yes, so it fits within our window. So we have a fixed window with big lift to load, to load, sail, and then unload, and then they're off to the next job. So we've had to plan that duration very carefully to make sure we've got enough time.
Great question. So it's slightly variable, and we're hoping it to be as short as possible and as cheap as possible. We've got a yes. Thanks.
Yeah, just a question around the budget. Yeah, sorry, just a question around the budget. So what's the current budget? And then maybe without divulging sort of facts and figures, what's the sort of the split between sort of the design component, you know, maybe the Timaru component, you know, maybe the shipping type of thing, and sort of the on-site component. I guess there's a lot of other big things there, but as a percentage, I'd expect you better to rattle that off the top of your head there, Ian.
So I think it's fair to say that we've got some commercial negotiations to go on ahead of us. So I think the program of record is 344 million all in, and out of that there are several components. There is the wind farm that we're looking to replace, and that's just over 30 million. We have a temporary base, and there was a budget for that, and we're hoping, because of the way we've approached it, it'll be less than the figure that's been set aside, which shows some great innovation. And then the balance is basically split between Antarctic work and Timaru work, plus there's a bit of logistics. So I think I'll keep it as vague as that if I can. The next question to me will be, is that enough? And I think we all know that there are lots of challenges facing us at the moment. So the team continue to look at innovative ways to value manage and value engineer, but there comes a point where we would compromise what we are going to deliver. So we're being kept honest by AECOM, who are our QS at the moment on this, and we continue to look at ways of driving cost out, but we recognise there are challenges globally to what we're trying to do.
Is he putting his nuts on the line for the fixed price contract?
And I think that'd be completely...
I'll be very interested to hear John's answer.
Look, what I will say is, and I had the pleasure of going south with some of the Leeds team this last season, and it was an absolute pleasure working. First time actually I've met Ian in person, and Will actually tonight, but we've done a lot on Zoom. You know, Leeds are invested in Antarctica, New Zealand, and Antarctica. I've had the pleasure of talking to Anthony about this, and this is really important to all of us. So, you know, we're going to find a way through that we can both all recognize success at the end of it, because we want it to be successful. Were there any questions online? I thought I may have seen one that pop up in the questions.
What is the main source of power? Does the wind farm generate enough power?
So that's probably a good question, probably from one of my own team who have dialed in. So at the moment, we actually have a smart grid that's maybe not quite as smart as it perhaps should be, given its age. So we share the renewable energy generation that we have from the existing wind farm with McMurdo. They have generators there, and the aim at the end of the day is to generate the majority of our energy demands using electric. And having sat in with Hugh on some of the fixtures, fittings and equipment conversations, we're looking at obviously not using gas anymore, which we currently use in Scott Base, moving to electric, which creates induction hobs and a whole new set of cooking paraphernalia that I've never even heard of. So it is changing the way that we will use energy in the future.
Another one is, do you have Netflix or similar on board or ready to produce a TV documentary on the project?
Again, another inspired question. And one of the things I got, we are capturing stop motion time lapse footage as we go. And I think I'm right in saying, Sam, we have partnered with somebody or are partnering with somebody to capture this in a documentary form. I don't think it's Kevin McLeod. I'm sorry.
How will the assembly team incorporate learnings from construction and install methods from our commercial ski areas in New Zealand?
Know the answer to that. Yeah, I guess there's the construction itself in Timaru is obviously straightforward with regard weather and conditions. The assembly on site, yeah, I mean, there's quite a few people come from the ski industry and work at Scott Base, so particularly around field safety, we use a lot of their knowledge from that. Plant maintenance, there's quite a few mechanics that work on the mountains that come down and carry out work on site there. So, yeah, I mean, we'll be casting the net in the next year or two to find good people from, whether they're from ski fields or Alaska or wherever, to help with this project. So yeah, it's some of the equipment's very similar to that is used at in the ski mountains. So yeah, we do use mainly from an operation and maintenance point of view as the key learnings from the ski field industry.
There's another one here from an emergency management point of view. Can you tell us about capabilities to isolate compartments and buildings from each other electrically and atmospherically whilst maintaining power and redundancy to enable safe havens and crisis management?
Yeah, so the building is designed to basically have a number of muster points within the shell, so within the heated space. It's pretty unique. Most bases in Antarctica are not all fully linked together. The smaller ones are, but most of them are sort of collections of buildings sort of scattered around a site. And in, what's called condition 1 weather, where you can't see your hand in front of your face, going outside when the building's on fire is quite difficult and dangerous, obviously. So there's a number of routes to get to various different places in the buildings. There's also 3 generators, gensets, and 1 in each of the buildings. And also there's a link to McMurdo for power and so on. So there's a high level of resilience with respect to all the critical life services. Unlike one of the Spanish bases a few years ago in the middle of winter, someone went a bit troppo and burnt the place down, and they spent the rest of the winter in a small portacom with the guy that burnt the building down. So we're trying to avoid situations like that. Yeah.
There's one more here. Well, how will the from a design basis, what has driven the 2-story approach for the buildings as opposed to 3-story or 1-story?
Yeah, so there's a kind of balance, I guess. First of all, as I explained when I was showing the site plans, on the restrictions around the site. So there's not that much space to build all the requirements for the new Scott Base. So that drove us away from a 1-story building. Then there's the management of wind and of snowdrift around the site. And so the bigger the obstacle you place to the wind, the greater the snowdrifts you get, the more you have to do to manage those. So it was a kind of optimization between the amount of real estate available and the impacts of high wind, which led to the 2-story solution, making it as efficient as possible, both in terms of space, but also as efficient as possible in terms of snowdrift management. So that was what led that solution.
What interest and advice from the US team, ? How does the current McMurdo stack up against future Scott Base?
Who wants to answer that?
Could you just start the question again?
What interest and advice from the US team? How does the current McMurdo stack up against the future base? McMurdo, sorry.
Is that a question about the advice that we sought, or advice we would give to the US program? I mean, we had a call just a couple of weeks ago with the US program, and we're very closely aligned. You can imagine, given all the logistics challenges, because we share literally everything. We understand their challenges, and almost nothing we do is done in isolation, because there's almost certainly an impact with the US program somewhere. So we're in regular dialogue. They're going through their own modernization program, the AIMS program at the moment, also impacted by COVID. So there is a really regular dialogue about the pressures and the ideas and the opportunities that exist for working together. And I think that is really important. They've got challenges with a backload of science programs that need to be undertaken, and a modernization that's going to go on at the South Pole as well, which I couldn't think of anywhere almost more complicated or difficult to try and get to. So we share regular advice and ideas together, particularly around the wind farm as well. That's something which is at the heart of both our teams' planning. Yeah.
When you're transporting the modules, how do you have the winds so the weather doesn't get in there?
Yeah, 50 mil insulated panels are fixed on the ends of the modules to keep the weather out, with a seal going around the joint. And then when the modules arrive on the site and they're positioned, those panels are stripped off, and then the modules are jointed back together. So you have it, basically it's a kind of sacrificial panel, I guess, almost, that's used to close those end caps off.
When Hugh says seal, it doesn't mean seal. It means seal. No seals will be harmed in this process. Okay, just conscious of time. Is there one more question? Nothing else online?
How do the SPMTS get to site in Antarctica by big lift ship or C-17?
Some on the ship and some containerised, so they'll arrive on site before the ship arrives. And the ones on the ship are wrapped to keep the seawater off them.
I have to say, being on the big lift ship going south with the modules is probably a once in a lifetime thing. So there'll be people queuing up to see and be part of that journey, even if it is across the Southern Oceans, which I have done, and it is quite sporty. I'd just like to say a particular big thanks, not just to the team, some of whom I've met for the first time this evening, and hopefully we've satisfied your curiosity in presenting some of the logic behind what we're about to do. But in particular to Sam, who's a very important team member for us, at the heart of a really excellent comms team who are putting what we do out there. And you can connect with us on social media, and we have got a Scott-based redevelopment website, so please do go and Google us, as well as the Antarctica New Zealand one, and obviously there'll be the colour campaign one coming along. It is just the most amazing thing to be part of. What we do is amazing enough as it is. What we're going to be able to do in about 5 years' time is going to be absolutely in a different league. And I think that is amazing for all those that will use the facility, but for Aotearoa New Zealand. And I think that is something very much to look forward to. And it will be something you can not just follow, but it will be built on your doorstep, and it will be almost try before you buy. We'll see it in Timaru, and we're really looking forward to working with Leeds on that. So can't be more excited about it. And we're very happy to talk more over a drink in a couple of minutes, but thanks very much for inviting us to come and speak to you. Thanks.